Hello everyone, my name is Dr. Tango Anderson Gaji, and I'm also referred to as Tern or Dr. Tern. Let me stop the cam. So in our last recording, we did model evaluation and we also compared uh, the two models one that was not, that did not include the interaction terms and the other that did. Kind of like we tried to re-engineer. So today, and then I said that we'll be moving on to how we can bring in the data into Power BI, and then start making some, storytelling. But before that, we are gonna stick to the syllabus. I want to compare what we have with IBM. Let me just highlight that. Which IBM SPSS, and I want to use the Andrew Hayes' method to compare what with that. Then after that, then we'll move into the Power BI. So sorry, I took you guys. I don't want to jump ahead of everything. So let's get started. First off, what I'm gonna do is I'm gonna pull out the IBM. By the way, this means International Business Machines. I think it means statistical package for social sciences. Yeah. So, right. So that is good. So next, I'm going to bring in the data set uh, that we downloaded on the website. Again, this will be the data set. I'm going to I brought in CSV format as well as regular Excel format. So let me go in there and bring it in. So I'm going to go File, Import. I'm going to prefer the Excel version. Yeah, let me go with that. Okay, I'm going to say remove leading spaces from string values and also remove trailing spaces from string values. And then I'm going to hit OK. Perfect. Now let me put it this way. Let me just bring this to this other side of the screen, and then I'll bring the VS Code to the other side of the screen, and then in IBM SPSS to run your regression model, you go to Analyze. By the way, I did two types of. If you watch my series, and I always recommend that you should watch them because it will help you a lot in terms of knowing how to predict and also build predictive models and evaluate how they perform, the performance. I did this regression analysis here, so I'm gonna do that also in SPSS to compare. So I'm gonna go Analyze, Regression, Linear. Okay, our predictor value was insulin. Then let me start all over. Our criterion variable, that is the dependent variable, was insulin. And then our predictor variable, all the regressors, will be age, gender, and BMI. This is just going to be a regular multiple regression. So let me hit statistics here. I want to include Durbin-Watson, covariance matrix. No need for R-squared change now, but I might do that later. Actually, it's going to be included in the Andrew Hayes model. So I'm going to hit continue. Plots. Let me just include histogram, normality plot, continue. Options. I think this looks okay. Style won't do anything. And then that is just it. So we're going to go ahead and hit OK. Now let's see what the outcome will be like. Again, I'm going to bring the outcome to this screen. to the other side of the screen, and then we'll compare. Okay, so we have our R square of 0.339. Let's check what we have here. Same thing, so it matches. That's perfect. The W1 thing was 1.945, which means that there's no autocorrelation between the residuals. Same thing here, it matches. Okay, so that is good. So the F here was that 388.6. Okay, so that is here 388.6. Let me just put it away. So it's something at 388.6. So it was the overall model was statistically significant. Same thing here as well. Actually, everything here looks statistically significant from all of the variables, just like the C is down here. See, everything here is less than 0.005. For gender, let me just start with age. For age for gender 0.002, for gender 0.002. Everything pretty much matches. So yeah, so this is pretty good. Next, we're gonna run the regression model that included their interaction terms. So let me scroll all the way down there, and let us do that. Perfect. This is the histogram. There were no significant outliers, although I see that one is up here, but that should be not, but it's still bell curve, so that is good. For the PV plot, a couple of, this is not like very close to the 45-degree line, so that is fair. So let's go ahead and run another regression that will include the interaction terms. I'm gonna use Andrew Hayes' model now to do that, specifically model 3. If you refer back to the books I recommended that you should read. So we're gonna go with regression. Now, instead of coming here to linear, we're gonna click on Andrew Hayes. You can download this extension, go on the website, and then you get it. Okay, now again, our criterion variable or dependent variable was insulin. Our predictor variable, main predictor variable was BMI. First moderator would be age. I'm going to put it down here. And then our second moderator is gender. I'm going to put it down here. And then very, very important, select model 3, because this is going to be moderated moderation. Also it is referred to as three-way interaction model. I'm going to come over here, options. I will select show covariance metrics, generate code for visualization. What else? Pairwise contrast for indirect effects. I'll just do that. Then for the conditioning values, you can select these, but I like to select like the standard, below 1 point below standard deviation and then 1 over standard deviation, and then I also like to select Jensen-Neyman output. I'll hit OK. I don't think anything else here is necessary, so I will just hit OK. Okay, so it's gonna take a while for the output to generate, so let's wait. Perfect. So let me move it out to the other side of the screen. Now let's compare. The R square here says that it is 0.3597 R square. So here is it, 0.36, which if you have to approximate is going to be about the same thing. The F statistic here is 182.17, which is about the same thing if you approximate. That is good. The degree of freedom is 7, same thing. That is good. Now let's check how well this accounted for how the statistical significance. Let me just put it that way. So age significantly it predicts insulin. It, so this is jumbled up here, but I would usually do this. I usually do this. Coefficients. I just count 1, 2, 3, 4. So same thing. I'll just count here 1, 2, 3, 4, or just count the third of our output from your right hand side. So age here says that it's not statistically significant. That's interesting. But body mass predicts insulin here. Is it statistically significant? Same thing as here. Now, for the interaction terms, you can interpret it them down here. BMI to age, BMI to gender, age to gender, and then BMI, the full interaction model, BMI and age and gender. So if we come up here, let's start with the first one. It says that it is not that BMI and age does not statistically predict insulin. I think that matches with what is here because they're all above 0.05. Second, the second interaction is statistically significant, which is for BMI and gender. Here, it matches. It statistically, it is statistically significant and it predicts insulin. Third is going to be age and gender. So age and gender here, which is INT3, it does not, let me see, predict insulin. So it agrees with this. Now, for the full interaction model, this indicates that it does not that the interaction between BMI, age, and gender does not statistically does it is not significant because it does not predict insulin. That again pretty much matches this 0.549. My concern is why this here for age, here it is insignificant, but here age it is significant. That's interesting. But everything else matches, so that is the good news. So this is how you can. I like to use different data analytical tools to validate my findings, and this is what I'll go with. Overall, if I'm to choose what output that I would trust, I'm going to go with the Python because I do not know the algorithms that were in there. He is an authority. Will state that there's need for more research to validate these. If age actually moderates the interaction or predicts our insulin amongst patients. Anyway, thank you so much. And in our next video, we will be using Power BI to build dashboards and make some sort of storytelling and present how what the data set is saying, what after the insight that we have derived from these inferentials. Thank you, and have a nice day. Looking forward to see you in our next session. Bye.